Alright, so today we are going to work on this problem. Now, I'm going to make the statement, plain and simple, factor. Can we do that by the methods we already are familiar with? Maybe not. The reason I'm writing this up here and asking the question is because we can't. Elijah, close your Chromebook, pay attention. So, the reason I'm asking this is because we can't. Because the thing is, all of our primary factoring methods, the box method, basic factoring, factoring out, none of those deal with x to the third, right? We have one factoring method that does deal with x to the third. What is it?
X to the third.
One factoring method that deals with x to the third problems.
No, it's the one we did somewhere.
Factoring by grouping, right? Factoring by grouping. Factoring by grouping deals with x to the third. Now, the thing is, even if we were to group this, is there any way we could factor something out of these and make them match? No, there's not. So factoring by grouping is not even going to work here. So we are going to have a third, or not even a third, but another process of being able to factor something out. Now this is directly related to synthetic and long division of polynomials. Because the thing is, if we can figure out a factor of this polynomial, then we can synthetically or long division or long divide it out of the problem and turn this into a problem we can factor through more traditional means. Now the problem is figuring out what it can be divided by. In the past couple of days we've done these problems where we have done synthetic and long division, but we haven't been able to figure, but we've always been given a binomial to divide these by, a binomial to take out. Here, we don't have that binomial. We have to come up with what it might be. Aiden.
Is it like x plus or minus 6?
Is it x plus or minus 6? That's a good guess, but no. Here's how you do it. There's no surefire way to take this information and say, this is it. Absolutely, this is our factor. But we do have a way to do this. We have to make a chart. So, draw this chart with me.
I don't like charts. I don't like charts.
We're going to have a chart like this, and on the left side, you are going to have factors of the first coefficient. And up top, in this chart, we are going to write factors of the constant. Elijah?
Yes, sir.
Why don't you write down your notes and follow along?
I have a body.
So, we have factors of the first coefficient and factors of the constant. So what I mean by that is we're literally going to list all of the factors of these numbers. Now, can someone in here tell me what is the first coefficient in this problem? 1. The first coefficient is going to appear right here. It's the number outside of our first term. In this case, that is 1x cubed. So what are factors of 1? 1. That's literally it. So I'm going to write a 1 in this side of my chart. Now along the top, I'm going to write factors of the constant. What is my constant here? Negative 30. Now the thing is, the fact that it's negative for the first time in our lives does not actually impact anything. This could be positive, negative. All we care about is the 30. It's almost like an absolute value. I usually always say you got to keep that sign, but here we just consider it 30. What are factors of 30?
2 and 15.
So 2, 15, what else? You got 6 and 5, 3, 10, 1, 30. Any others?
No.
No, that's all of them. So what I'm going to do is I'm going to write all of these factors across the top. 1, 2, 3, 5, 6, 10, 15, 30, right? And now I'm going to kind of make a grid here. Sometimes we're not going to have a 1 out front here, so we'll have multiple rows to this grid. But in this case, we just have one row and a lot of columns. we are going to make fractions out of this. The top is the numerators. The side is the denominators. So I will write 1 over 1, 2 over 1, 3 over 1, 5 over 1, so on. Now you can notice all of these are going to be over 1. It's not actually that necessary to write something over 1, right? But if I had multiple different factors to my first coefficient, then I would be having some of these over 2 or over 5 or something like that, and they'd get a little bit more complex. But you're just going to have these. So what happens is these numbers inside the boxes that we made out of our chart are the possible factors to this polynomial. Now here's the thing, Madison says there's so many. 1, 2, 3, 4, 5, 6, 7, and 8 of different ones, right? But that's not all. Because here's the deal. These can all be positive or negative. Whoa. So there's actually 16 potential factors, which is a lot. I grant you that. That is a lot of factors. How do you think we take these potential factors and determine which one it actually is? What do you mean by put it into the equation?
So like write it as a binomial and solve it.
Okay, so Madison says maybe try some trial and error actually doing synthetic division with one of these. Believe it or not, that works. That is a method. It's a high effort method, shall I say. But there's another method that maybe, it's also still kind of high effort, but it's another method. The other method is if this is a factor, if one of these is a factor, it is also a root of the equation. Now we talked about roots earlier this year. What are roots? Something that makes the problem equal 0. Roots are values that make the problem equal 0. So one of these, or actually the multiple of these, because if this is x to the third, 3 of these 16 are going to be factors. If this is to the 5th, then 5 of your amounts are going to be factors, that kind of thing. We only need 1. So what we have to do is if one of these is a factor, it's also going to be a root. Meaning if we plug it into the equation for x, we are going to get 0. So what I'm going to do is I'm going to have us try out a couple of different numbers. So Madison, Dawn-Ann, I want you all to take 1. Holly, Justin, and Linda, take -1. Aiden and Elijah, take 2. Keegan and Brody, take -2. Nate and Caleb, take 3. And I will take -3. Plug it into the equation for x. Grab a calculator if you need to. And if you get 0, you found a factor. So I'm going to see what you all get. We're going to try this out, and then we'll see what happens. Madison. It'd be 1 cubed plus 6 times 1 squared minus 1 minus 30, yeah. So I'm going to try out -3. You plug it into the equation for x, and if you get 0, then that turns out it's our factor, or it's our root. So I'm doing -3. That was the one I assigned myself. So I'm going to plug this in for x, and we're going to see what we get. If we get out a 0, we found our factor. If we don't get out a 0, it's not a factor. Yeah. It's a lot of work. It's trial and error. I agree with that. It's tough. To make it cubed, you do this. 1 to the 3rd. And then you have to hit the over button. In place of the x. I will be right there, Aiden. I will be right there. Let me finish writing this real quick.
We got one.
Okay, hold on to that number. We're going to keep talking about it.
Like your number was right. No.
I know what's right.
Oh, so you said that we did 2 times 2 times 2, 2 times 2, plus 6 times 2 times 2. 6 times 2.
Elijah, you should be working on this. Brody, you too.
We're already done.
We're done. Well, I think that would be
Okay, we're going to go over this tomorrow. Alright, you guys should have been saying, you guys should have been working on this. Now, to give you an example of what I did on mine. Alright, to give you an example of what I did on mine. Whatever number you were assigned, I was assigned -3. If we plug that into the equation for x, then you want to see what it will equal. So what I did is I took the equation right up here, and I replaced every x with my number. So instead of saying x cubed plus 6x squared minus x minus 30, I have -3 to the third plus 6 times -3 squared minus -3 minus 30. Now, whenever I cube -3, I get -27. -3 squared makes 9, so the 6 and the 9 are going to multiply to 54. Minus -3 is actually going to be plus 3, and then minus 30 doesn't have a variable, so it doesn't change. Now, I'm going to add all those things together, and I got 0. Now, is that a good or a bad thing? It's fantastic, because if I get 0, it means it is a factor. Now, Madison, did you all get 1 to be a factor or a root?
Well, if we did it right, no.
No, it's not, because you got not 0. Holly, you guys, did you all get -1 to be a root? No, you did not, unfortunately. Aiden, what about 2? Okay, so 2 worked. 2 was a root. That is huge. Brody and Elijah, did you all get yours to be a root?
Just me and Aiden. It's Keegan and Brody.
My bad. Keegan and Brody, did you all get yours to be a root? No. Nate and Caleb? Not sure, but I'm going to say no at this point. But we've identified 1, the class identified 1, and I identified another, -3. Now the thing is, as Madison said a little bit ago, we just need 1 of these. We need 1 root. As soon as we have identified a root, I'm going to use the +2 that Elijah and Aiden identified. We can determine a polynomial or a binomial that would be a factor of this. Elijah, sit down. I'm going to be moving you if I got to say this again. So we can find a binomial that is a factor of this polynomial. Now, anytime we put a number inside that synthetic division, in this case it would be 2, it makes it equal 0. When that was in binomial form, it would have actually been x what? -2, because remember we always flip the sign to get it over here. Because you always would go through the process of flipping the sign to make it into binomial form. That's what we always did in synthetic division. And that's what we're doing here is we're saying this is a number that if we synthetically divided this by, we would get a 0. It would come out perfect. So we have identified x minus 2 as a factor of x cubed plus 6x squared minus x minus 30. So if we did this as synthetic division, x cubed plus 6x squared minus x minus 30, we could divide it by x minus 2, and we would actually get somewhere. Let's synthetically divide it. We have 2 in our box already. 1, 6, -1, -30. Put a plus sign, leave a line. Drop the 1, multiply it by the box. 2, 8. 8 times 2 is 16. 15, multiply by 2 gets 30, and 0. Meaning if we divide out x minus 2, we get x squared plus 8x plus 15. I'm going to write that right over here. X squared plus 8x plus 15. Is this a number? Now that we have started the factoring process, we identified something that could come out of this. We identified a factor. Can What are factors of 15 that add up to 8?
5 and 3.
5 times 3 makes 15. 5 plus 3 makes 8. So x plus 5, x plus 3. Those are our two factors of our simplified version, but don't forget we also had x minus 2. This is our fully factored form of our original polynomial.
How do you do that?
We're going to explain.
I'm trying to.
Okay, so what happened is after we synthetically divided out the 2, we got x squared plus 8x plus 15. We recognize that's a polynomial, a basic polynomial that we can factor through regular means. We always, when we have just a basic factoring polynomial, we look for factors of the last term, factors of c that add to b. Factors of 15 that add to equal 8 are 5 and 3. 5 times 3 is 15, 5 plus 3 is 8. So we're just doing basic factoring, like Algebra 1 factoring on that. This process is a little tiring. Truth be told, we're not going to be doing this process much in class. I'm going to have maybe one question over this. It is a grueling process. I want you to be aware it exists, but it is not something we're going to be doing on any sort of a regular basis. So fear not on that front. But it can be difficult. Nate.
I'm likely really lost in all this.
Okay, we're going to go over another example. Fear not, Nate. All right, if you have any questions, let me know. Comment, like, subscribe, and don't forget, always say goodbye.